Right now, while you are sitting inside your home, there may be a chamber of damp air collecting directly beneath your floor. Not outside, not in your bathroom, not in the attic, under your house. And every hour that air remains trapped there, it can begin moving upward through cracks around plumbing lines, electrical penetrations, floor seams, and framing gaps into the rooms where people sleep, eat, and breathe. Most homeowners never think about the space below them. Why would they? You mow the lawn, you clean the kitchen, you change the air filter. But the crawl space? That hidden cavity beneath the floor often disappears from memory entirely. And that is exactly what makes it dangerous. Because problems you cannot see have a strange way of growing quietly, sometimes for years. Most people blame allergies on pollen, dust, seasonal weather, maybe poor ventilation. But building inspectors and moisture specialists have spent decades discovering something many homeowners never consider. The air inside your house may not be coming primarily from outside at all. A large percentage of indoor air can originate from below. That idea sounds backward at first. Fresh air comes through windows, vents, doors. That is what we assume. But homes behave differently than most people realize. Your house is not simply a box sitting still. It behaves more like a breathing structure. And once you understand that, the entire crawlspace problem begins making uncomfortable sense. Because trapped air below the house rarely stays below the house. It moves, slowly, silently, relentlessly. And the mechanism behind that movement is older than electricity, older than air conditioning, older than modern construction itself. There is a principle in building science called the stack effect. The name sounds technical. The idea is simple. Warm air rises. Every child knows this. But most homeowners never realize what that means for an entire building. When air inside your home warms up, it naturally rises toward the upper levels and roof. As it rises and escapes through small leaks and openings above, it creates a subtle pressure difference inside the structure. And nature hates imbalance. So replacement air gets pulled in from wherever the house can find it. Doors, windows, wall gaps, and very often the crawl space. Your home behaves like a slow-moving chimney. The top leaks outward. The bottom pulls inward, which means the space beneath your floor may be participating in your indoor air supply every single day. Without your permission, without your awareness, without making a sound. Now here is where the story becomes strange. Because older builders often worked very hard to keep the underside of a house dry and ventilated. But many modern homes accidentally do the opposite. Moisture enters and then becomes trapped. Rainwater runoff, poor drainage, damp soil, condensation, blocked vents, improper grading. Even simple humidity moving through soil can create conditions that slowly accumulate beneath a home. And once moisture becomes trapped in a dark enclosed space, something else begins to happen. The air changes. Wood stays damp longer. Humidity rises. Odors appear. Sometimes mold develops. Sometimes insects arrive. And sometimes homeowners notice symptoms upstairs long before they ever look below. That musty smell, the heavy air, the feeling that something in the house never feels completely dry. The crawl space was never meant to become a swamp hidden beneath the floor. Yet many homes accidentally create exactly that. Imagine a shaded cavity beneath your home. Little sunlight, minimal air movement, cool surfaces, moisture lingering longer than it should. This is not automatically dangerous, but it is an environment where conditions can begin shifting in ways most people rarely monitor. Mold does not appear because a house is old. Moisture creates the opportunity. Stagnant air extends it. Organic material feeds it, and crawl spaces contain plenty of organic material. Wood framing, dust, paper-backed insulation, debris. The result can become what some inspectors informally describe as a biological chamber beneath the home. Not because the crawl space itself is evil, but because trapped moisture changes the environment, and once conditions change below, the air above often follows. That is the part many homeowners never connect. They treat symptoms upstairs, while the source remains downstairs. Modern houses often respond to moisture with machines, dehumidifiers, powered ventilation, air treatment, mechanical drying. And sometimes those tools are absolutely useful. But here is the uncomfortable question. Why does the problem exist in the first place? If moisture keeps returning, if dampness keeps forming, if the machine must run constantly, then perhaps the machine is not addressing the original cause. It is managing the consequences. That question led me towards something unexpected. Not a laboratory, not a contractor showroom, but communities that solved moisture problems long before powered equipment became common. And that is where the Amish approach enters this story, because their thinking began somewhere different. They did not start with machines. They started with ground, air, and prevention. The first thing many traditional builders understood was almost embarrassingly simple. Wet ground changes everything. Dry ground changes everything too. Long before humidity sensors and digital monitoring existed, builders paid close attention to what happened underneath structures. If moisture lingered below, problems followed above. So instead of sealing dampness inside and hoping equipment removed it later, they often focused on preventing stagnant moisture from collecting in the first place. Air had to move. Water needed somewhere to go. The ground beneath the structure mattered. And one surprisingly simple material kept appearing in traditional approaches across different regions and generations. Sand, not decorative sand, not beach sand dumped randomly beneath a floor, but sand used as part of a broader strategy involving drainage, airflow, and moisture management. At first glance, it sounds too simple, almost disappointingly simple. But sometimes simple systems survive for generations for one reason. They work. And what sand actually does underneath a structure turns out to be far more interesting than most people realize. When most people hear the word sand, they think of beaches, playgrounds, concrete mix, not home health, not airflow, not moisture control. And that reaction makes sense. Because modern construction rarely talks about sand as part of a living moisture system beneath a house, but older builders often did. Not because sand was magical, and not because they misunderstood science. Quite the opposite. They understood something painfully practical. Water behaves differently depending on what it touches. Clay traps. Mud holds. Organic soil stays wet. But clean sand behaves differently. It drains. It separates. It breaks moisture pathways that otherwise linger close to wood and flooring. And that difference matters more than most homeowners realize. Here is something builders learn quickly. The ground beneath your home is never truly dry. Even during summer, even after weeks without rain, moisture moves upward from soil continuously through a process called capillary movement. You do not see it, but it happens. Water vapor travels upward from cooler ground toward warmer air. And if that vapor encounters surfaces where airflow is poor, it lingers. That lingering moisture becomes the beginning of many crawlspace problems. Not dramatic floods, not burst pipes, just quiet dampness accumulating month after month. And dampness is patient. Wood absorbs it. Insulation sags. Odors build. Air quality changes slowly enough that homeowners often adapt without realizing it, until the house no longer feels fresh, only familiar. Before powered ventilation became common, builders relied on geometry. Air needed direction. Openings needed purpose. And movement mattered more than force. The Amish did not invent airflow. They respected it, because moving air behaves differently than trapped air. Moving air dries. Moving air equalizes. Moving air discourages stagnation. And stagnation is where trouble begins. Many traditional homes used carefully positioned crawl vents or foundation openings designed to encourage cross-flow beneath the structure. Not random holes. A pathway, one side pulling, the other exhausting. The principle is almost identical to how barns stayed dry long before electric fans existed. The building breathes, and when the underside breathes, the structure above benefits. Now here is the part that surprised me. Several traditional builders describe placing sand beneath structures not as decoration, but as a working layer, and once you understand the physics, it begins making sense. Sand drains quickly. Unlike compacted clay or damp organic soil, clean sand allows water to move downward instead of lingering near the surface. That alone changes moisture behavior beneath a structure. But the second effect matters even more. Sand dries faster. because it allows air and vapor to move differently. Instead of creating a damp sponge beneath the home, it creates separation, a buffer between wet soil below and structural materials above. Not perfect protection, not magic, but a smarter starting point. And older builders often preferred systems that reduced problems before they became expensive. Have you ever entered an old basement or crawl space and immediately noticed something? That smell. Not always mold, not always rot, just heavy air. People struggle to describe it, but they recognize it instantly because human bodies detect stale environments remarkably well. Air that has not moved, moisture that has not evaporated, organic compounds building slowly in confined spaces. And here is the uncomfortable part. That air does not necessarily stay below. Remember the stack effect. Your house is pulling from somewhere. If crawl air becomes stagnant, part of that environment may eventually participate in indoor circulation above. Not dramatically, not like smoke pouring through vents. Slowly, continuously. And that is often why homeowners notice symptoms without obvious explanations. The source is quiet, the movement invisible, but the effect accumulates. Now, this is where the conversation becomes controversial, because modern construction often prefers sealing. Seal the envelope, seal the moisture, seal the airflow. And in some situations, that logic works. But sealing only works when moisture is fully controlled. If dampness remains trapped beneath a structure, sealing can turn management into storage, and storage is not removal. A crawl space that cannot dry becomes dependent on constant intervention. Fans, electricity, equipment, monitoring. The Amish approach often started with a different question. Not, how do we force this space to behave? But, how do we prevent unhealthy conditions from forming? That shift in thinking changes everything, because prevention costs less than correction, and airflow costs less than machinery. There is a strange economic pattern in home maintenance. The longer a problem stays hidden, the more expensive it becomes. A little moisture becomes damaged insulation. Damaged insulation becomes floor problems. Floor problems become repairs. Repairs become contractors. And somewhere along the way, homeowners begin treating symptoms instead of causes. What struck me about older building logic was its simplicity. Keep water moving. Keep air moving. Keep wood dry. The system is not glamorous. Nobody sells subscriptions to airflow. Nobody trademarks dry ground. And sand sitting quietly beneath a structure does not look impressive enough for a showroom brochure. But quiet systems often last the longest. And before I explain the exact crawl space airflow setup traditional builders used to keep these spaces dry, there is one question we need to confront first, because it explains why so many houses today struggle beneath the floor, and why the problem may have started long before you bought the house. Here is something few homeowners like hearing. The condition of your crawl space often has very little to do with whether you are careful, or clean, or responsible. Many houses inherit problems. A contractor closed vents decades ago. Drainage changed after landscaping. A gutter failed. A previous owner stored debris below the floor. Or building practices shifted toward faster construction without fully understanding how moisture behaves beneath living spaces. And by the time you buy the house, the system underneath may already be struggling. That matters because homeowners often blame themselves for symptoms that began years earlier. The smell, the dampness, the uneven air. Sometimes the crawl space has been trying to tell its story for decades. Nobody simply listened below the floor. Now let me show you the logic older builders followed. Not superstition, not mystery. Airflow. The idea was simple. Moisture must leave. And for moisture to leave, air must move. Many traditional crawl systems relied on cross ventilation. An intake side, an exhaust side, not necessarily powered, just positioned. Air enters low, crosses beneath the structure, carries moisture with it, and exits elsewhere. The principle is identical to how a shaded porch feels cooler than trapped air behind closed walls. Movement changes conditions, and when airflow beneath a house remains consistent, wood dries more effectively. Humidity struggles to collect. and the crawl space behaves less like storage and more like part of a functioning environmental system. The old builders were not trying to overpower nature. They were cooperating with it. That difference matters. This is the part many people expect to be complicated. It usually is not. The traditional approach was layered. First, water management. Rain directed away. Gutters functioning. Ground graded properly, because airflow cannot solve standing water. Second, ground separation. Often through sand or other draining material that discourage surface dampness from lingering beneath framing. Third, air pathway. Openings kept clear. Crossflow encouraged. No stagnant dead zones. No sealed damp pocket beneath the structure. Notice something important. The system works together. Sand alone is not the answer. Ventilation alone is not the answer. Drainage alone is not the answer. The power comes from cooperation between all three. That is how older systems survived. Not through a miracle material, but through balanced design. Now, if you own a house, this part is for you. You do not need special tools, and you do not need to panic. You need information. Start outside. Walk the perimeter. Do gutters overflow? Does soil slope toward the foundation or away from it? After rain, does water collect near the crawl area? Then look below if access is safe. Use a flashlight. What does the ground look like? Dry? Muddy? Heavy odor? Damaged insulation? Blocked vents? Signs of long-term moisture? You are not looking for perfection. You are looking for clues. Because houses rarely fail suddenly. They communicate gradually, and moisture usually leaves fingerprints long before serious damage appears. I remember speaking with an older builder once who said something I have never forgotten. He told me, "A house talks to you if you pay attention." At first, I thought he meant noise, creaking floors, doors, settling, but that was not what he meant. He meant systems, dryness, air, light, the feel of a room. Older builders noticed these things because they depended on them. They did not have machines quietly correcting mistakes in the background, so the building itself had to work. And perhaps that is what fascinates me most about traditional approaches. Not nostalgia, not romance, responsibility. The idea that comfort begins with understanding how a structure lives and how it breathes. There is a reason ideas like this resonate with people. Because many homeowners feel trapped inside systems they do not fully understand, something feels wrong, and the only solution offered is usually more equipment, more replacement, more cost. Sometimes that is necessary, but sometimes the first step is simply understanding the mechanism. Moisture, air, drainage, pressure. Once you understand those forces, the house becomes less mysterious and perhaps less intimidating. The crawl space stops feeling like hidden territory. It becomes part of a system you can actually observe, maybe even improve. That shift matters more than people realize, because capability changes how a home feels, and how a homeowner feels too. So before we close, I want you to remember something. This story was never really about sand, and it was never just about airflow. It was about attention. The underside of a house is easy to ignore because nobody sees it. But hidden systems shape daily life more than visible ones ever do. A dry crawl space rarely gets credit until moisture arrives, until air changes, until the house begins asking for help. The builders who understood this were not trying to create perfection. They were trying to create resilience. A house that could stay healthier because it worked with natural forces instead of depending entirely on mechanical correction. So here is what I want you to do. This weekend, take a flashlight. Look beneath your house if you safely can. Tell me what you find. Dry sand? Damp soil? Blocked vents? Standing water? How old is your home? And what is happening underneath it right now? I read those stories. And often, what people discover below the floor changes how they understand the entire house above it. If this kind of practical building knowledge speaks to you, the kind rooted in observation, airflow, and systems that worked long before modern complexity, then stay with me. The next video explores how traditional underground cooling chambers used earth temperature and airflow to keep food and living spaces remarkably stable without electricity. You may be surprised how simple the physics really is. Until then, stay curious. And pay attention to the spaces most people forget.